Hello?
Okay, isn't clear?
No, sir.
Hello?
Hello?
No? Okay, just please wait.
Okay.
Okay, it's all right. Now, is it clear? Screen presentation, is it clear?
Yes, sir, clear.
Okay, it's all right. Now, today, has already last we have to start the Riemann integration. Now, Riemann integration. What is the Riemann integration? Now, here the integration is defined by Riemann. He is one of the great mathematicians also there. Last class already we have discussed the some Riemann concept is there. Okay, thank you. Now, hello. Okay, now to the already later class we have explained the Riemann integral concept. What is the Riemann integration? Now just you have to define the when the one of the line integral. What is the line integral? Any integral which can be evaluated along the line that is called a line integral. Now according to the line integral we have to discuss the initial point and the terminal point. Suppose integration is noted integration as noted as integral a to b f of x dx. That is the proper integration. There are two types of integrals, proper integral and improper integral. In the last session, now we have to complete the discussion. It is very too clear here. Now here the enter the concept. We have to explain the Riemann integrability concept. What is the partition? According to the line, we have to discuss the interval points. What is the interval points? Integral a to b. Now every line integral must be defined on the closed interval, especially Riemann concept must be defined on closed interval ab. What is the closed interval ab? Here on the line integral a to b means that is the initial point and the terminal point. Now we have to discuss the here x being any one of the element, that element is consisting of interval a to b. Here x belongs to closed interval ab means a less than or equal to x less than or equal to b. That is the concept of closed interval ab session. Now here x is consisting, one of the element is there. There are instead of x is denoted by put a equal to x naught. Here x naught, we can deviate the points of according to the elementary session, x naught, x1, x2, so on up to xn. In between orth subinterval is also there. Now according to these are all partition points in between a to p. Okay. Now here a equal to x naught and the terminal point b equal to n is there. Suppose integral x naught to xn instead of integral a to b. Now this hello.
Hello, sir. University. Sir, my pair, sir.
Hello.
Okay, sir.
Srinivas Rao, sir.
Continue, sir.
Yes, today's okay, sir. Thank you very much. Hello. Now this session especially we have to discuss the complete the concept of Riemann integration. Riemann integration means especially the integral points, interval points must be defined on the line concept. Integral a to b f of x dx is there. Okay. Now here the already we have discussed the partition point. And according to the points, partition points, we must construct the subintervals. Now, in between a to b, Subinterval points are x0, x1. That is the first subinterval. X1 and x2, x3. Now that is the second subinterval. And x4, x5. That is the third subinterval. Now all those subintervals denoted by I0, I1, I1, I2, I3. These are all subintervals are there. Every subinterval must have a one of the length. Every subinterval must have a one of the length. Okay. That length is denoted by del naught or del 1. Mod I1 means length of I1. That is called del 1 is there. Mod I2, that is denoted by del 2. And a mod I3, that is denoted by del 3. Now these are all length of the subintervals. All the length of the subintervals, which is the maximum length of the subintervals is called. Please, students, listen carefully. Now, this concept is much more useful in a further session. And in the undergraduate level, we have to discuss the Riemann integral. Concept, the Riemann integrals concept and Riemann-Stieltjes integrals, because every mathematician or any one of the scientists, now some mistakes are there. Now here the interval, according to the interval points, we have to construct the line integral is there. And that integration concept is integral sin x dx equal to minus cos x. And constant, here the forgot it is there. Here constant means the constant must be eradicated through by Riemann. But Stieltjes must be rectified. That error is there. Especially that is called Riemann-Stieltjes integral. Now, here in the examination point of view, here the one of the important point, the number of subintervals are there. All the subintervals, every subinterval must have a of the length is there. So listen carefully here. Just see the 7.2.2 is there. Very important definition. Okay. Now P be the partition. If P equal to set of x0, x1, x2, so on, xn. It is a partition of I equals to closed interval AB. Then we get non-overlapping subintervals. Non-overlapping subintervals means now closed interval x0, x1. And again, closed interval x1 and x2. And so on. Closed interval xr minus 1 and xr. And so on, closed interval xn minus 1 and xn. Now, these are all subintervals are there. The maximum length of the subintervals, every subinterval, listen carefully, every subinterval must have a one of the length. So, just you have to see here, first subinterval is I0. That is x0 and x1 is the first subinterval. Length of the subinterval is denoted by del naught. So, that is length of I0 is there. That is x1 minus x0. That is the length of the first subinterval. In the same manner, second subinterval is x1, x2. That is I2, I1. And length of the subinterval is L of I1. L of I1 equals to, that is del 1. That is second subinterval is x1, x2. Length is x2 minus 1. So all the those subintervals, that is called is denoted by listen between in subintervals x is 1 and x is there. XR is there. Now the length of phi r equal to del r. What is the length of the subinterval? That is the length of the subinterval means r subinterval length is dash. Now this is a multiple choice question. Length of phi r equal to del r equal to xr minus 1. What is the r? Closed interval xr minus 1 and xr. So in the same manner, length of in equal to xn minus 1 and xn, that is the in interval, nth subinterval is there. Okay. In the same manner, length of in equal to xn minus 1. In the overall, the subintervals of the length, overall the subintervals of the length means del naught plus del plus x2 minus x1 plus x3 minus x2, so on, xr minus 1 plus so on xn minus 1. After the simplification, we are getting the result is xn minus x0. Okay, here xn equal to b and x0 is a. So overall the interval is length of I equal to or del of I equal to whatever it is, there is no problem. Okay, so that overall the length interval is closed interval AB. What is the length? Mod closed interval AB means b minus a. Now here according to that maximum length of the subintervals is called, that is called the norm of the partition. Norm of the partition is denoted by double mod P. Student, please rectify this one. You see, just see in your textbook is there, especially 7.2.2. Now here mod modulus means now mod is entirely different. Is the modulus of this concept. Now double mod of P means double mod P is it read as norm of the partition. Now instead of delta of P, so that is a partition. Okay. Now what is the common refinement? There are so many partitions we must define on closed interval AB. Okay. Now P star is called here the common refinement of the partition. Common refinement is the union of any two partitions is called common refinement. Now that is very simple for P star or P dash. For here P star is called common refinement of the partition. Now that is common refinement of the partition means a P1 union P2. Simply defined as common refinement P star equal to P1 union P2. Okay. So see the definition you see in your textbooks, especially now interval defined on the F is defined from interval AB to R. Here interval AB means that is the consisting of the element. That element is defined. That element is consisting of interval of the part. That interval is closed interval AB. Okay. Now closed interval AB is the domain of this part, and as when the codomain of the part is on the real line of this part. Now here the function is defined by f from closed interval AB to R, be a bounded function, PB any partition. Now every the system of writing concept is here, especially through the Riemann. Every theorem must be depends upon the functional concept. Here, F maps interval AB to R be a bounded function, and PB any partition. That partition is a defined set of in between A to B, x0, x1, x2, so on, xn. Be a partition of closed interval AB is there. That's enough. Now here, what is the everyone is here? Okay, there are so many partitions in between the interval points. Now every subinterval is must be involving infimum and supremum. Every subinterval is defined lower bound and upper bound values. Those values depend on the function, and according to the depends upon the functional values, we have to define the infimum and supremum values. Now we are taking the first subinterval. Now that is I0 I1 is the first subinterval of this part, and now in between the I0 I1 equals to interval x0 to x1. Here x0 is the lower bound value and x1 is the upper bound of the value. Now those values please stay on the line. Some students is also okay. Now here the interval x0 to x1 is there. Now x0 x1 is one of the subinterval is there. X0 is the lower bound value and x1 is the upper bound of this value. And according to this one, x0 is the lower bound and x1 is the upper bound of the value. Those values must be depends upon the function. Now already function is defined. That function is either there are so many functions are there. Algebraic function, trigonometric function, exponential function. There are so many functions. But here, especially we are taking the algebraic function is there. F of x equal to x square. That is the second degree function is there. f of x equal to x cube, that is the third degree function, and f of x equal to x power n. Here, all the integral powers must be represented as the positive integers. Here, n belongs to z plus. Okay. Now here, x power n means that is the nth degree polynomial part. Okay. Now here, especially those values must be defined upon the function. You must define the infimum and supremum. Now suppose first subinterval m1, put k equal to 1 is there, m1, put k equal to 1 is there, capital M1. Here small m is the infimum of this part. Infimum means that is the greatest lower bound. Supremum means least upper bound. Now already we have to discuss in the primary part of real analysis, that is the real number system. What is the completeness axiom? Any non-empty set of real numbers which is bounded above has a supremum. Now, according to the supremum of this value, supremum and infimum. Now we have to discuss some problems are also discussed in the primary part, how to find the infimum and supremum values. Now, just you have to see the screen. That now share on the screen, please. Now that is mk equal to, what is the mk? Infimum of the function. Capital mk is the supremum of the function. Now, according to the infimum and supremum of the values, now we have to define the lower Riemann sum and upper Riemann sum. Already last class we have to discuss it. It is too clear here. Now what is lower Riemann sum and upper Riemann sum. At the same time, Riemann sums, that is also called Darboux sums. D-A-R-B-O-U-X, Darboux sums. Okay. Now at the same time, lower partition of f, partition of the function of the lower value. Just see in this screen, please. Just see on the screen. Lower Riemann sum is L. Now that is also called, we treat as lower partition of f, or lower Riemann sum m, or lower Darboux sum. Now that is the similar names. Partition according to the function. Now that function must be defined through the closed interval AB. We have to discuss that there are so many partitions. So many partitions. Now just you have to discuss the one of the partition is capital P. P be any partition of closed interval AB. Lower partition of f equal to summation small mk. Mk means infimum of the kth subinterval. Del k means length of the subinterval. Okay. Now del k value is sk minus 1. Okay. Just you have to see here. Now simple division, define lower Riemann sums. There are two types of Riemann sums: lower Riemann sum and upper Riemann sum. Lower Riemann sum is or lower partition of f, or lower. There are three similar names instead of Riemann sums. One over here, lower and upper. Lower, now lower partition or lower Riemann sum through the infimum of this concept. Now sum of the overall all those subintervals of the infimum and length of the subintervals of the summation is called lower partition of f. Summation mk of sk minus 1. Okay. Okay. Just please stay on the line. Now L of pf equal to summation mk of sk minus 1. Simply that is denoted by summation small mk and del k. Here k equal to 1 to n values. Okay. That's enough. Now let us on the next page. Just to see here. Upper partition of now upper Darboux sum or upper Riemann sum. There are three similar names Riemann sums. Okay. U of pf means upper partition of f, or upper Riemann sum, or upper Darboux sum. Summation capital mk of sk minus 1. Summation capital mk and del k. Here, what is the del k? Kth subinterval of the length. That value is sk minus 1. Okay, students, there are two type of Riemann sums. Still you have to explain here. And according to the Riemann sums, now there are one of the important result is there. There are so many theorems are there. There are number according to the functional of the interval. We have to construct the so many partitions. P any one of the partition. P dash is the P1 is one of the partition. Another partition. There are unit two partitions. The union of or the sum of unit two partitions or the union of unit two partitions is called common refinement. That is denoted by P star equal to P1 union P2. This is also according to the partitions, the deviation of the partitions. Just you have to say this is the observation of graphs here. Lower Riemann sum means L of PF less than or equal to U of PF. Just you have to see the 7.2.5. This is the simple proof. L of PF less than or equal to U of PF. Already we know that WKT. We know that the definition of lower Riemann sum and upper Riemann sum. Lower Riemann sum L of PF equal to summation K equal to 1 to n. Small mk del k, that is the lower Riemann sum. Upper Riemann sum equal to U of PF, that equal to summation k equal to 1 to n capital mk and del k. So it is too clear here. Now, according to those partitions, what is the comparison? The comparison between lower Riemann sum and upper Riemann sum, especially you have to see here 7.2.5 through the geometrical interpretation. According to the geometrical interpretation, lower Riemann sum is always less than or equal to upper Riemann sum. Now, this is not necessary here, especially because lack of time. Okay. Now, another theorem is also there. Just you have to see and 7.2.6 according to the different partitions, how to discuss some relations of throughout the partitions, lower and upper. Okay, next, just see this one, 7.2.7. This is one of the important results. Just see, okay, according to the partition of the interval, we are taking any two partitions, P1, P2. Any two partitions is consisting, P belong to P of closed interval AB. P1, P2 be any two partitions is consisting of interval AB. Now, first partition of lower Riemann sum less than or equal to second partition of upper Riemann sum. Sir, how to derive the different partitions of lower and upper Riemann sums? Okay, now it is clear. Please just try to understand this result. Okay, according to the unit two partitions, now L of P1F is less than or equal to U of P2F. So we are taking any two partitions, P1, P2 be any two partitions here. Okay, first partition is defined. It is defined on lower Riemann sum. Important relation. Now C and all discuss just use P star equal to the union of any two partitions equal to that is the common refinement of this part. It is denoted by P star. P star equal to P1 union P2. This is one of the much more important result in the final examination. Okay. Now, what is the proof of L of P1F less than cannot exceed the U of P2 of F? Okay, now just you have to see and verify the result is there. And through the common refinement, L of P1F cannot exceed the L of common refinement of the function. And in the same manner, L of already we know that lower Riemann sum less than or equal to upper Riemann sum. Through the common refinement, U of P star of F is there. Okay, so final result is now U of P star of F means common upper Riemann sum defined upper Riemann sum through the common refinement of the function cannot exceed the upper of second partition of F. So our final conclusion is L of P1F less than or equal to L of P1F means lower Riemann sum on the first partition cannot exceed the upper Riemann sum on the second partition. Now, this is the very students. Now, this is one of the important results, 72.7. Okay, next one. Now, Riemann integrals are also two types. Students, listen carefully here. Onam and DT. Or do you follow here? Okay. All students are, we must hear. Can you hear me? Hello?
Not clear, sir.
అది కట్ అయిందండి. Please stay on the line. Hello?
Yes, sir.
Okay. Some disturbance is there, signals problem. Please stay on the line.
Okay, sir.
Please stand the line, student. Now, already we have to discuss the Riemann integrals concept is there. Now, the Riemann integrals two types. Riemann integral and upper Riemann integral. I can say. Okay. Hello, students. Please stay on the line. Okay. Now you have to see the integral. Now, according to the concept is here, especially lower Riemann integral is denoted by integral lower limit a to b f of x dx. Already we have to discuss this one. Just you have to see and refer this one. Hello, students.
Hello,
Just
sir.
see on the screen is share screen is that
Yes,
screen is shared. Or okay, it's all right. Now, just you have to see the 7.2.9 definition is there. Okay. What is the lower Riemann integral and upper Riemann integral? there are two type of Riemann integrals here. Especially every now integration is defined on the real line part. Now, according to the real line integral a to b, when the initial point coincides with the terminal point. Now, just to just a schematic diagram. Just to think schematic diagram according to the line, that is the one of the closed part is there. Now that is called integral a to b f of x dx. Now here a is the lower limit, lower value, and b is the upper value. According to the lower value or lower limit, now I have to define the function is denoted by lower limit a to b f of x dx. Now here that is what is the lower Riemann integral? Short form as LRI. LRI means lower limit a to b f of x dx. Now LRI means lower Riemann integral. That is supremum of lower Riemann sum. Supremum of lower Riemann sum. That is denoted by supremum set of lower Riemann sum. Already you have to discuss the lower Riemann sum is there. According to the lower Riemann sum, then their supremum value is called lower Riemann integral. Now here P be any one of the partition of the interval. Now according to the upper Riemann sum means U of PF. Upper Riemann sum means U of PF. Now then their infimum is called upper limit a to b f of x dx equal to infimum of U of PF, such that P be any one of the partition. Now it is too clear here. There are two type of RIs. RI means Riemann integrals. Lower Riemann integral, upper Riemann integral. Now, here upper Riemann integral means integral upper limit a to b. Upper limit a to b means b is the upper value. Now that is the identification of b bar. Okay, it read as integral upper limit a to b. It read as upper limit a to b f of x dx equal to upper Riemann sum of the infimum value. Upper Riemann sum of the infimum value, that is called upper Riemann integral. Now when those lower Riemann integral equal to upper Riemann integral, that is called Riemann integral. It is very important notation when the LRI equal to URI. Lower Riemann integral equal to upper Riemann integral, that is called Riemann integral. That is denoted by RI. Means lower limit a to b f of x dx equal to upper limit a to b f of x dx equal to integral a to b f of x dx. That is the Riemann integral. Okay, it is very important concept is there. Next one. Okay, here can be the value. Infimum and can be the supremum of the value. Now, what about relation lower Riemann sum and upper Riemann sum in between the infimum to supremum of the values? Now every theorem must be involved. This especially this result is there. 7.2.10. Just you have to see and refer here. F be any one of the bounded function. Bounded function means when the interval of the function. When the function must be defined on the real line, that is the interval points. Then the interval must be closed, that is called the bounded function. Now FB bounded function real. Now those interval points supremum, such that infimum is denoted by small m and the supremum is denoted by capital M is there. Now equal to infimum of small m equal to infimum of f of x, such that x belongs to I. Capital M equal to supremum of the function, that is SUP, supremum short form as SUP, set of f of x. Here such that x being the interval part. Here P be any one of the partition. Now there are so many partitions through the interval of the part. Now P be any one of the partition. Here P belongs to P of I. P of I means a pi of closed interval AB. Pi of means that is the number of those partition sets. We have that. What about the relation? Already we have discussed one of the important result is lower Riemann sum is less than or equal to upper Riemann sum. That is L of PF less than or equal to Q of PF. Okay. Now, just you have to see and hear. L of PF means already we know the definitions. Summation, small mr and del r. Okay. Small summation, small mr and del r. U of PF means capital MR and del r. Now, those values lies between small m of P minus A and capital M of P minus A. Now, that is the simple relation. When the lower Riemann sum is less than or equal to upper Riemann sum, lies between small m of P minus A and capital M of P minus A. Now, that is one of the important result. Now, according to the relation, now just see here. Small m of B minus A less than or equal to Riemann integrals concept. That is, lower Riemann integral is less than or equal to capital M of B minus A. And capital M of B minus A less than or equal to upper limit A to B f of x dx less than or equal to capital M of B minus A. Now, it is here. Now, that is small m of B minus A less than or equal to lower limit A to B f of x dx less than or equal to B minus A, and upper limit upper Riemann integrable function is less than or equal to capital M, small m of B minus A. Student, please rectify this one. Just see and erase this one. This result is small m of P minus A less than or equal to upper limit A to B f of x dx less than or equal to capital M of P minus A. So, overall, the Riemann integration lies between small m of P minus A and capital M of P minus A. Now, that is one of the important result. Integral A to B f of x dx lies between small m of P minus A and capital M of P minus A. Okay, that's enough, students. And one of the Riemann integrals concept, every lower Riemann integral equal to upper Riemann integral. Okay, now that value is an equivalent to Riemann integrable. Okay, this is also one of the important relation. Lower Riemann integral equal to upper Riemann integral equal to Riemann integrable. That is the definition of 7.2.11. Okay. Now, 7.2.12. Lower Riemann integral cannot exceed the Riemann integral. Already we have discussed that the lower Riemann sum cannot exceed the Riemann sum. In the same our Riemann integral cannot exceed the upper Riemann integral. Okay. Now this is one of the important proof is there. Now we have to discuss. We are taking the any two partitions defined on partition of the interval. First lower Riemann sum less than or equal to the Riemann sum of the upper part. So that is L of P1F less than or equal to U of P2F according to the above result. Just you have to see and refer the above result. It is then now that is the upper bound for the set of lower sums L of P1F. But the supremum of lower Riemann sums of the supremum part. Now that is called lower Riemann sum of supremum part is called lower Riemann integral. That is lower limit A to B f of x dx. Okay. Now see the continuing of this part. Lower Riemann integral cannot exceed the upper second partition of upper Riemann sum. Lower Riemann integral less than or equal to U of P2F. Now that is the meaning of lower Riemann integrable function. It is the lower bound. Now lower bound of the set of all upper Riemann sums. Now a lower bound of the greatest value is called infimum of this part. So second partition of upper Riemann sum, we are construct the infimum of this part. So finally a lower Riemann integral less than or equal to upper Riemann integrable. Okay. Now that is also one of the important result. Now these theorems are also very important of this part. Now in the examination, Darboux theorem 7.2. This is one of the one of the most familiar theorem throughout the Riemann integration. Okay, Darboux means that is the closed part. Of the mathematician is there. Okay, now that mathematician is also discussed throughout the Riemann integrals concept, and before he was explained the relation between the Riemann integrals and Riemann sums. Now that's why here. Now see the statement of Darboux theorem. This is one of the most important theorem. Students, please listen carefully. 7.2.13. Now this is one of the familiar theorem. Darboux concept. Okay. If f is a bounded function, just see the definition. F is a bounded function on closed interval AB and epsilon is greater than 0. There exists del greater than 0 such that is the statement of Darboux theorem. Upper Riemann sum are equal to upper Riemann sum less than upper Riemann integral plus epsilon. One of the relation. Now the comparison between upper Riemann sum and upper Riemann integral and lower Riemann sum and lower Riemann integral. Now that is the Darboux especially was defined in between the relations Riemann sums and Riemann integrals. Here epsilon be any number. That number must be greater than 0 is there. Okay. So upper Riemann sum means U of PF less than upper Riemann integral means integral A to B. B just you have to observe this one. The B of the above bar is it read as upper limit A to B f of x dx plus epsilon. Upper Riemann sum less than upper Riemann integral plus epsilon. Lower Riemann sum is greater than lower Riemann integral minus epsilon. Here PB any one of the partition from the partition set is defined on closed interval AB with the partition of the norm about the relation. This is the statement. It is given and sometimes the multiple choice is also there. Norm P less than del or greater than del or greater than 0 or less than 0. Whatever it is. Her norm P is always norm of the partition is always less than is there. Okay. Now see and refer this theorem by definition of upper and lower Riemann integrals. Through the definitions, first of all, so we must write the definitions. Lower limit A to B f of x dx equal to supremum of lower Riemann sum and another partition of Q is there. L of Q or Q and F. Q be the another partition from the partition set. So lower limit A to B. Just you have to write the definition of lower Riemann integral and defined the another partition of the set. Supremum of L of QF. And upper Riemann integral equal to infimum of U of QF. What is the Q? Q be the also partition. So since the upper integral is infimum of U of QF and U of QF and L of PF.
Baba, no dear.
Let's see this one. That is the Darboux theorem statement. Okay. Now, here according to the proof is here, by definition of upper and lower Riemann integrals, no, just you have to observe this one. And U given F less than you have, there are so many partitions divided into that, what, how to give in the result
Yeah.
of epsilon. Epsilon by 2 plus in there. Hello? Please mute all the, please. Hello, students, please mute is there. Now, you have people here Riemann sum on the first partition. That's the upper Riemann integral plus n by 2. Now, this is the statement of, this is the proof of Darboux theorem. Now, the value is a partition of the value. You can choose del 1 be any number. That number is lies between 0 and epsilon. Here P be partition of closed interval AB. Now here P is one of the partition hello, please try to understand my situation. Hello, please mute the students. Now, what about the relation? P1 equal to upper Riemann integral plus epsilon by 2. If the number of points in P2 which are not in P. Okay. Now the final P is denoted by del 1 is there. Now that is the simple proof. So partition upper Riemann sum on the second partition plus 2k into L del 1 less than upper Riemann integral plus epsilon by 2 plus 2k into m del 1 is there. Finally, that value less than upper Riemann integral plus epsilon by 2 plus. Now, value is equal. So finally, we are getting the result is upper Riemann sum less than upper Riemann integral plus epsilon. Similarly, we can prove that lower Riemann sum is greater than lower Riemann integral minus epsilon. So enter all the partition. Minimum of del 1 and del 2 is denoted by del is there. Here finally, the epsilon gradient 0 such that upper Riemann sum less than upper Riemann integral plus epsilon. Lower Riemann sum is greater than lower Riemann integral minus epsilon. Okay. Please stay on the line. Students. Now, this is one of the important relation, one of the important theorem. Just you have to see and refer one of the important result, especially in the final examination. Darboux theorem is Darboux theorem much more important theorem. Throughout the Riemann integrals concept, in the final examination, this theorem must be, there is no doubt. Okay. Now already given in the paper is there. Now just see and refer this theorem. Now Darboux, he was discussed about the upper Riemann sum and upper Riemann integral, and one of the second relation between lower Riemann sum and lower Riemann integral. Okay. Now what is the conditions of Riemann integrability? Now just see and refer 7.2.14. This is also in the final examination, multiple choice is also there. Okay. Upper Riemann sum of the limit point. Upper Riemann sum of the limit norm P tends to 0. equal to upper Riemann integral. Lower Riemann sum of the limit norm p tends to 0 equal to lower Riemann integral. This is also one of the important result, and throughout the norm of the partition through the limit point of the upper Riemann sum and Riemann sum. Upper Riemann sum of the limit norm p tends to 0 equal to, that is upper Riemann integral. Lower Riemann sum of the limit norm p tends to 0 equals to lower Riemann integral. This is also one of the important result is there. Students, now in this session especially, this theorem is one of the important theorem necessary and sufficient condition of P. Now this theorem is very much more useful and very important in the final examination. Without this theorem, we cannot expect the question paper, especially. Okay, that is the conditions for Riemann integrability. A bounded function F maps. What is the statement of necessary and sufficient condition of Riemann integrability? A bounded function F from interval a to R is Riemann integrable. First of all, given the function is Riemann integral. Necessary and sufficient condition means if and only if. Okay. Now, function, when the function is Riemann integrable, if and only if epsilon is greater than 0, there is a partition P of closed interval AB such that what is the difference between upper Riemann sum and lower Riemann sum? Already last class we have to discuss, it is there. Oscillatory sum. What is that? Oscillatory sum. U of PF minus L of PF. Now, that is denoted by W of PF or O of PF is there. So, oscillatory sum is less than epsilon. 0 less than or equal to U of PF minus L of PF less than epsilon. This is the one of the important theorem, necessary and sufficient condition of Riemann integrability. Okay. A bounded function F from interval AB to R. Please see in this one. This is the one of the important theorem in the final examination. Without this theorem, we can't expect the final examination. Okay, especially in the real analysis. Now enter all those theorems depends upon this theorem especially. Okay, first of all, a bounded function F maps interval AB to R. When it is the Riemann integrable means lower Riemann integral equal to upper Riemann integral. Now that's why that is called integral A to B F of x dx. Now here the partition will be such that 0, that is U of PF minus L of PF less than epsilon. Now here the proof is there. Just see and see the proof. First of all, what is the necessary part? Given the function is Riemann integrable. What is the meaning of Riemann integrable? Lower Riemann integral equal to upper Riemann integral equal to integrable A to B F of x dx. It is called integrable function. Now, by Darboux theorem, already we observed that the relation Darboux theorem, upper Riemann sum less than upper Riemann integral plus epsilon by 2, lower Riemann sum is less than lower Riemann integral minus epsilon by 2. Okay. Now, according to the partition of the interval, norm P is less than del. Using first condition, what is the first one? Here, just you have to see this one. First one means, first equation means function is Riemann integrable. And comparing the result is U of PF less than upper Riemann in the replacing of second equation. U of PF less than upper Riemann integral plus epsilon by 2. That is the second equation. L of PF is less than, that is the lower Riemann integral minus epsilon by 2. That is the third equation. Now comparing the second and third equation by using first equation is now replacing the integrable values, lower and upper Riemann integral values, U of PF less than integrable A to B F of x dx plus epsilon by 2, and L of PF less than that value is also equal to integral A to B F of x dx minus epsilon by 2. In the final version, just you have to see this one. Now, from the third equation and the first equation, integral A to B F of x dx, L of PF less than lower Riemann integral plus epsilon by 2. Now plus epsilon by 2 converting into this side. Lower Riemann sum plus epsilon by 2 is less than integral a to b f of x dx. Okay, that value integral a to b f of x dx is greater than or less than integral a to b f of x dx less than L of pf plus epsilon by 2. So these values is substituting upper Riemann sum minus lower Riemann sum. Integral a to b f of x dx. That value is lies between u of pf minus L of pf less than epsilon. Because epsilon by 2 plus epsilon by 2, that is 2 epsilon by 2. 2 epsilon by 2 means epsilon is there. So the just you have to backward part is there. Okay, integral a to b f of x dx, that is already integral a to b f of x dx means upf plus epsilon by 2, and that value is an equivalent to upf minus lpf converting into this side, upf minus lpf. Okay, so integral a to b f of x dx value is substituting in the above part, that is u of pf less than L of pf plus epsilon by 2 plus epsilon by 2. So lpf converting into this side, left side, upf minus lpf less than epsilon by 2 plus epsilon by 2 is epsilon. The oscillator sum less than epsilon. We know that the definition of upper Riemann integral definition and a lower Riemann integral definition. Upper limit a to b f of x dx equal to infimum of upf. Now, what about the relation upper Riemann integral is less than or equal to upper Riemann sum? In the same manner, lower Riemann integral definition is there, supremum of LPF. So, here, lower Riemann integral is greater than or equal to lower Riemann sum. Or negation is also applied here. Now, negative is also applied here. Minus lower Riemann integral less than or equal to the negative of lower Riemann sum. Finally, upper Riemann integral minus lower Riemann integral is less than or equal to UPF minus LPF. Already we know that sum is lies between 0 and epsilon. So oscillator sum is less than epsilon is there. So finally, Riemann integral minus lower Riemann integral less than epsilon is there. So then epsilon means that value is greater than 0. Now finally we are conclude that upper Riemann integral equal to lower Riemann integral. So that's why this is called when the lower Riemann integral equal to upper Riemann integral. That function is Riemann integral. That function is Riemann integral on closed interval AB. Okay. Now this is the simple statement of f is Riemann integral on closed interval AB is denoted by f belongs to R of AB. F is Riemann integral is denoted by f belongs to R of AB. ORR, lower Riemann integral equal to upper Riemann integral equal to integral a to b f of x dx. Now that is the simple concept of necessary and sufficient condition of Riemann integrability. Students, listen carefully. Now, this is one of the important theorem in the final version. Now, when the function is integrable, means when the lower Riemann integral equal to upper Riemann integral equal to Riemann integral. When the function is Riemann integral is denoted by f belongs to R of closed interval AB. R means Riemann on closed interval AB. Okay. Now, students, this is the end of the session is here. Today we have explained Riemann sums and Riemann integrals and Darboux theorem and some partitions theorem, and necessary and sufficient condition of Riemann integrability is there. Now this is much more useful in the final examination, and later we must discuss the next class properties of Riemann integrals. Properties of Riemann integrals through the continuous function and derivable function. Now those results are when the function is continuous, that continuous function is always Riemann integral. That theorem is 7.3.2. Okay, and when the function is monotonic, that monotonic function is also Riemann integral. Okay, now next class is also we will discuss as an briefly part. Okay, through the complete description through the screen presentation. There is no doubt, students. Now enter all the notes must be posted through the WhatsApp. Already WhatsApp group is created, and some notes through the important theorems must be shared in the WhatsApp group is there. Now there are so many theorems and so many important theorems and important conclusions, important results, especially in the already posted through the WhatsApp group. UG third year real analysis group is there. Okay, any student must be deviated in this group. Please note down my number and join this group. Okay, thank you, one and all. Hello.
Thank you, sir.
Okay, ma'am. Wish you all the best. And once again, wish you good luck. If you have any doubt, please discuss it through the WhatsApp. Okay.
Okay, sir.
Thank you. Thank you, one and all here. Wish you all the best and wish you good luck.
Thank you, sir.
Thank you, sir.
Most welcome.
Mama. Mama.